All right, here we go. This is problem number 39 from the Halliday and Resnick textbook. We're trying to calculate the ratio of the drag force on a jet flying at 1,000 kilometers an hour at an altitude of 10 kilometers to the drag force on a prop-driven transport flying at half of that speed and half that altitude. So it's giving us density of air, so blah, 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 blah. All right, so here we go. So we've got a jet, and we've got a transport, right? All right, so we are given that the jet is traveling at some velocity, let's just call that v, and that the transport has a velocity of half of that, right? And then, let's see, what else do we know? We know the density of air, so let's see, for the jet, the density is going to be, let's call this density J. That's going to be 0.38 kilograms per meter cubed. And the density for the transport, because we're at a lower altitude, the air is denser. So that's 0.67 kilograms per meter cubed. All right. Now, they've both got the same area, and they've both got the same drag coefficient. All right. And so what the question wants us to know is to find the ratio of the drag force for the jet. So we're looking for the ratio between the drag force on the jet and the drag force on the transport. Okay? So, well, and notice here I didn't write in the velocities. You'll see in a minute that the velocities, they kind of cancel out because of this ratio here. Okay? Anytime they give you a ratio like that, odds are you don't need the actual numbers. Okay? All right, so let's see. So the drag force on the jet. So drag force is 1/2 your coefficient times your density. I'm just going to plug in the numbers. Well, here, no, let me do this. Here's what I want to do. Drag force. Here's the equation for drag force in general. It's 1/2 your drag coefficient times your fluid density times your cross-sectional area times your velocity squared. That's the equation for drag force. So let's plug in our numbers over here. We're going to get, for the jet, we're going to get 1/2 coefficient times density, which is 0.38, times our area times our velocity squared. Divide that by the drag force for the transport. So that's 1/2, same coefficient, different density, same area, half of the velocity squared. And cancel stuff, right? So let's see. We've got the same coefficient. These 1/2s here cancel. We've got the same areas. The velocity squareds are going to cancel, so let's do this. So now what we've got is this. We've got 0.38 v squared over 0.67. Now 1/2 v squared is the same as 1/2 v times 1/2 v. Oops. So that's 1/4, so 0.25 v squared, right? So the v squareds cancel out. So you're left with 0.38 over 0.67 times 0.25, and you end up getting 2.3. There you go, and no units, right? Because it's just a ratio.